Hello, I'm back from a tiring day. I'm going to do another MAT Oxford question. This question asks to find the value of this equation. What we can do first is that we can split the sine cube. Firstly, realize that sine x cubed is equal to sine cube x. Let's draw cos squared here for completeness. Whoops, it almost went out of ink, but don't worry, it's got enough ink for us to do this question. Sine x cubed can be split into sine x squared. Sine x equals to cos squared x. Sine x squared can be written as you might see on the cube, like this. Now, what we want to do is that we want to make everything in this side a multiple of cos x. What are we going to do? We are going to introduce an identity. Let's box it up because it's super important and will also be used later. Making sine squared x a subject. Sine squared x changes to 1 minus cos squared x. Sine x equals to cos squared x. We multiply. And finally, we make sine x a subject. The reason why we make sine squared x a subject, sine x a subject is because we can easily factorize this expression into cos squared x sine x plus 1. We can immediately that sine x can never be equal to sine x plus 1. So that leaves us with the property that sine x equals to cos squared x. Now, in order for this equation to be true, one of these components must be equal to sine x. Then sine x plus 1 cannot be equal to sine x. We put sine x is cos squared x. Making cos squared x a subject in this wonderful identity. Okay, here's a joke about this identity. You know Pythagoras and his group, they really hated irrational numbers. Imagine what they would do when they see sines and cosines. And yet, this famous result is proved from the Pythagorean theorem. You can go look it up if you wish, but we do not have time to discuss it here. We will now solve this quadratic. We will make the left-hand side into a quadratic equation of sine x. So this is a quadratic equation of sine x. We see that sine squared x is sine x squared. And this also can be written as y squared plus y minus 1 equals to 0. To find how many solutions we had in this quadratic, we use the discriminant. B squared minus 4ac for any quadratic ax squared plus bx plus c. Now these x's can be any variable you like so long as it isn't a, b or c. Now b squared is 1 squared minus 4, 1 minus 1 equals to 1 plus 4 equals to 5. How do we solve this quadratic? Well, it involves the discriminant. We will mark the discriminant as d. The quadratic formula, as you might know, is that some of you might have introduced it to the back. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, b squared minus 4ac is the same as the discriminant, which is written as d is minus b plus or minus the square root of d over 2a. Since we already figured out b, which is minus 1, minus 1 plus minus root 5 over 2. Now the minus solution is less than negative 1, and because the range of sine x, let me draw it here, from 0 to 360, or in fact any value at all, neither surpasses 1 or negative 1. So we conveniently use this fraction line to cross out the negative. We'll draw a line at -1 plus minus root 5 over 2. Could be any positive solution, it's called A. And we notice that it crosses the sine curve at 2 points. So there are 2 solutions to the equation. We write that down. Which is option C. There you have it. This is a cubic equation in sine. You could do it the other way by doing a cubic equation, but then it will use a formula so horrifying called the cubic formula. It was used by Albert Einstein in his graduate studies. But we had never been taught the cubic formula, and we never will be. Most of us will resort to use a calculator, but since we all know the quadratic formula, I have reduced this to a quadratic. There you have it. This is how rather strange looking equation with sine on one side and cos on the other side can be solved. This method can be generalized to any, if any, methods of sine and cos. See you, bye! And besides, don't forget to like and subscribe to my channel and share these videos with all of your friends.